Good afternoon, everyone. My name is Jim Duffy. I'm a managing editor at Network World. I've been a trade reporter in the technology industry for 27 years, 22 at Network World. And today we're going to discuss the SDDC money flow, the economics, the budget considerations of implementing SDDCs, and pretty much software-defined anything. So I'd like to start with my panel and just ask everyone to briefly introduce themselves and what their role is in their organization's SDDC efforts. You want to start, Nils?
Yeah. So my name is Nils Swart. I work at Plexxi. We've got a number of roles, one of which is business development and looking after strategic partnerships. In that sense, we look at integration with external systems that are of high value to lots of companies in terms of integrating their infrastructure with higher layer application management systems. That's roughly it.
Okay.
Hi, I'm Andy Brown. I'm Group CTO at UBS. I've been working really on this problem for quite a long time, probably 20 years actually in total, both in the telecom industry and in finance. And what we've done in the last few years, well, the last 3 years, is really build out proper dev as a service, proper test as a service infrastructure, and been working really hard on getting policy at the very center of what we do. I believe that policy will become the most important factor in the implementation of a software-defined data center, because a pure software-defined data center without policy means that you're pretty much giving up on the configuration strategy, the security strategy, the risk management strategy that has seen us so well in silo world that we've lived in for the last 20 years. So you'll hear a bit about that from me today.
I'm Ron Sackman. I'm a network architect at Boeing. So Boeing is a large systems integrator, as everybody knows, and so we're looking at this not from a vendor perspective, but basically for the projects that we do for external customers, which is kind of my neck of the woods, with some complex inter-networking solutions for specific problems. We're looking to see just what is next generation, what's feasible. Our group here in Mountain View particularly is focused on cybersecurity, so we're taking a kind of a somewhat skeptical look at SDN and just from a security perspective, seeing if this is something that we could objectively recommend to a customer that might be a little bit conservative in terms of their technology adoption posture.
Hi, my name is Jon Hudson. I'm with Brocade, Principal Engineer in the Office of CTO. I also represent Brocade in the IETF. I'm the Secretary of the Troll Working Group and on the design team for NVO3.
I'm John Vincenzo. I'm what some might call the evil marketing guy from Embrane, whose job is to not let the facts get in the way of a good story. Actually, what I also do is make sure that what we do and how we're building and how we're talking about things are really closely aligned to use cases and real customer problems versus these broad statements that are nice to haves but aren't really realistic yet.
Not fun.
And I'm Inder Gopal. I'm here representing OpenDaylight. I'm the chairman of the board of OpenDaylight. And my day job is with IBM. I'm responsible there for networking products, in particular including all of the SDN offerings that IBM has and will have in the near future.
All right, thank you. Now, we heard from some previous presenters, Embrane, Coca-Cola, Nutanix, that software is everything. That things can be implemented in software now the way they couldn't be implemented, say, 15 or 20 years ago. How is that impacting your, First, I'd like to start off with Andy and Ron, our two end users on the panel. How is that impacting your IT budgets?
I think in a number of different ways, actually. So software being everything also means that you have a lot more choice. And in particular, open source prevalence, particularly around new projects, is a massive change over the last 3 years in our industry and in our company as well. The willingness to accept abstraction is kind of a trade-off between control of people and hardware versus control of software. And most operations people will tell you they don't trust software, right? So one of the things you have to do is win enough trust to be able to get them to adopt. And if we go back to 06, when I was leading the charge on deploying VMware in a prior life and did a pretty reasonable job at it, the biggest barrier to implementation was just getting operations people on board and comfortable with the platform. Now when you think about all the other kinds of software abstraction that we're now trying to introduce in parallel, someone's going to cry uncle soon, right? So you know, you've got SDN, you've got SDS, you know, software-defined storage, you've got software-defined security. All of these things need to interoperate with each other. Information protection and data obviously have to interoperate extremely carefully, right? So the way I think about it right now is the success of software-defined workload management, you know, aka virtualization and cloud, in a way has created a set of children, not all of which can actually be implemented in parallel, but all of which are required to get to the end state of a software-defined data center. So the question for me becomes, which is most likely to succeed next? And I think it's a toss-up. I mean, we've done a lot of work on Viper in my company, in software-defined storage. We've looked at the other 2 or 3 startups in that space as well. And there's a huge amount of cost takeout in software-defined storage that isn't necessarily there in SDN right now. And the reason it's not there in SDN is because people aren't ripping out the expensive under network and replacing it with SDN. SDN has become a cost-plus play. So I think when we think about which one's most likely to succeed in the short term, to me, software-defined storage probably has more legs than SDN because of the cost pressure, particularly in our industry. That might not be true in other industries, but we've got massive cost targets by the end of 2015. So I would, if I were backing horses, my favorite horse would be software-defined storage rather than software-defined networks for the reasons I outlined.
Ron?
Well, I think for some of the customers that Boeing would deal with, you know, U.S. government, international governments, kind of large customers like that, who may be a little bit conservative on technology adoption in a lot of cases. We have to present a pretty convincing story first of why do you want to do this in the first place. You know, I think there'd be a CapEx savings and OpEx savings. I'm just thinking of you know, we just won a proposal for a security operations center for a foreign government, for example, and I'm just thinking, well, the next one of these that we do, could we lower our could we have a better price point on our next proposal if we propose an SDN switch solution instead of some of the standard vendor switch solutions? So to go that far, I think there are a few things that have to happen before we would feel comfortable doing that. You know, just kind of the general state of maturity, but also just kind of, you know, if you look at it from a security perspective, to me, I personally, being a network architect myself, I feel like the best security, the best means of security for a network environment is a really good design of the network itself. So if you're concerned about data exfiltration, you want to make sure that the servers you're most concerned about don't have a direct line of sight to to the internet, different steps like that you can take. So in a lot of ways, I think things like layer 2, layer 3 VPNs really backstop your network security. The L2 and L3 have not historically been a big cyber attack surface in the industry, and so so my concern looking at this is, well, is the CapEx and OpEx savings that you're going to get by doing this going to justify the risk that you're taking by opening up a bigger cyber attack surface and something that hasn't been a problem to this point, or at least is a largely mature, solved problem, I think, is the way I would describe that. So, and then the other thing that I think is an area of concern that I haven't heard a lot of discussion about is in terms of the actual software development itself that would go into an SDN implementation. What sort of assurance does someone have, particularly if a lot of this is open source software, that the software that you're integrating into your solution is itself going to be secure? And how do you scan that? You can look at Coverity, you can look at some different vendors like that. But there's a big development time security vector that doesn't really exist as much at this point that I think is a concern. So I think those are some of the questions that would need to be overcome. I think the the CapEx and the OpEx savings are potentially very compelling and something that could be really interesting. And there are some specific use cases I personally see for SDN that I think would be great if it could solve some specific problems and pain points that we're seeing. I'll get into those in another question. But I think just in general, security is a big concern, and particularly if you think about a data center environment where you have potentially competitors coexisting as different tenants in the same data center. What if someone develops some code that's going to poke a hole in the L2 VPNs within that data center and exfilter data between Coke to Pepsi or whatever scenario you want to come up with. So to me, those are some of the things that I would be concerned about and would want to hear a compelling story of maturity before we would propose it.
Yeah, because that's a when, not an if. That's a when, not an if.
Now, are those issues keeping you from investing more in software-defined data centers or in software-defined networking technology? I'm getting the feeling that your IT budgets have not been dramatically changed with the wave of software-defined data centers and networking that we've seen over the last few years.
Yes, I think that's true. I don't. I actually am not privy to for the Boeing Enterprise Network, which is about last year is about the sixth largest network in the world. I work with them occasionally, but that's not my main job. So I'm not actually privy to their budgets. But I do not believe there's been. I know that they did a major segmentation project a year and a half ago, as I recall, and SDN was not part of that. So I know Boeing is taking. There's some people in the Boeing IT group that are starting to look at it at this point. The question I've been getting back from people as I kind of look for little niches to promote this within the company is, just why would we do this? If it ain't broke, don't fix it. Prove to me that there's a reason we should go do this. And particularly if you already own all of your equipment and the packets are flowing, you need a reason.
Mm-hmm.
So that's if we haven't, at least from what I can observe, I haven't seen my company come out and say, well, this is obviously the compelling use case for this, and we're going to go do it. Mm-hmm. Now, Boeing is not hosting multi-tenant data centers. That's not what we do. So we don't have that specific use case as a standalone enterprise. But yeah, we need a compelling use case for it.
Now, what about the vendors on the panel? Have your product development budgets been drastically changed, or are they more diverse now? Are they software intensive now?
So I'll speak for Plexxi, obviously. We are an SDN company, but we use SDN methodologies rather than sort of the standard, semi-standard set of acronyms that have been flowing back and forth in the media. And it's true that sort of 2/3 of your engineering staff are going to be on the software side. And that's been true for networking ever since networking kind of came around. So I'm sure this panel is not the one who's going to redefine SDN yet more, but this whole notion of software defined is kind of a misnomer. Everything is software defined. Budget-wise, we're clearly a software company, and large part of the intellectual property is on the software side in turning to mathematics and algorithms to optimize workloads inside of an infrastructure and optimize that infrastructure to make sure that those guarantees, be that security or performance related, can be offered sort of long term. Actually, sort of to add one point to that, I've heard it a number of times in the previous panels, if it ain't broken, don't try to fix it. That works really well if there are no changes in the requirements or changes required of the network. I mean, if the IT infrastructure were to remain static, no users added, no applications added, no additional offices open, for instance, then all of that will work great. But the reality is, as soon as you wire something up once or install an application once, the day after, the business requirements have changed, and as a result, change is sort of a given. So in that sense, I would kind of challenge if it's not broken, don't try to fix it. There's a big problem in sort of managing applications, managing the understanding of what's really needed in the infrastructure. So luckily, it requires software to manage software, and that's, I think, what we want to address. Yeah.
John?
Well, I was going to add that it's not just about the economics, right? Because a lot of this is also changing the way people think of things, right? I mean, since Viata joined us, it's certainly impacted the way certain people think of different problems and so forth. And so, you bring a team like that on, and it opens your mind a bit and gets you to look at things in different ways.
Yeah, at Embrane, I would describe us as forget the SDN acronym, we're a networking company, happens to provide that functionality in software form. So in terms of where our investment goes, it goes predominantly to the software piece. But I turned to a customer of ours and kind of where they're spending and what they're looking at in terms of where they're going to be spending their money. And they don't have an SDN budget. Right? There's no budget for them for SDN. They do, however, have a problem with segmentation in their data center because they were spinning off from their parent company and they needed to segment it. They shared a data center, need to segment it off. So what they did is say, I can start this process of making my data center more software defined, more agile, but I'm solving a real problem today, and it's easier for me to spend in OpEx than it is in CapEx because I have a defined CapEx budget. So he went ahead and said, you know what, I can do this today as part of my job. I can solve a problem. I can spin up your firewalls in 90 seconds and have it installed and give a dedicated instance that separates me from that, and I can do it on my OpEx budget. And so for him, it was like, I know I'm going to do, he said it point blank, John, I'm going to do something in this SDN thing later. I don't know what that is yet or when that's going to be, but I like the fact that I'm solving a problem today, and then you give me a platform for doing stuff later as I need it.
But keep in mind, I mean, IT budgets are like bottlenecks. You shift them. You never reduce them, right? I mean, budgets are not going to go down. They'll just get shifted into hopefully better opportunities for organizations to be more competitive, more nimble, and so forth.
But as you shift them, don't they go down in other departments? You shift more monies from hardware to software in order
Certainly could be a result, but the idea that 5 years from now you're going to be spending less on IT, I'm not sure I'd bet on that.
But it is a zero-sum game, right? I mean, you're absolutely right. If you spend more in one area, you've got to spend less in another area. I don't know too many enterprise customers that I've talked to that have IT budgets that are actually increasing, right? Most of them are actually probably shrinking, right? And but if it's interesting, if you look at the total data center networking spend, right, in enterprises on a worldwide basis, it is growing, right? It is growing at about 12-15% a year. But then you talk to any given customer, any given large customer, their budgets are shrinking or best flat. So there's got to be growth in terms of have new customers coming on board, maybe global markets. I mean, maybe emerging economies, cloud service providers. So there are new customers coming on board, and these guys obviously will have different patterns of spend than the traditional enterprise customers, and for them it's not necessarily a shift, it's perhaps more of establishing of the new normals that they have. But getting back to the other question about vendors shift within vendor budgets, right? I mean, I think the point was actually made earlier, so maybe I won't belabor it too much. But I mean, I honestly don't see much of a shift. I mean, if you see if you look at, say, a typical switch manufacturer building traditional Ethernet switches for data centers, 85% of the staff are software developers, right? And probably at least 3/4 of the spend is associated with software. And so it's really a question. I mean, that the software that they develop happens to be embedded software running, inside the switch for the most part, as opposed to software running, externally on a controller. So I don't necessarily see a shift between software and hardware investment, but I do see obviously a shift in terms of the kind of software that gets developed, and that obviously again will take some internal restructuring and internal reallocations within the various organizations.
Now, will that change as we see more and more network services housed on x86 servers like Nutanix showed in their presentation? First of all, do you agree with that paradigm? And secondly, will you see that 85% software become 95% software investment?
Yeah. I mean, firstly, I do agree with the paradigm. I mean, maybe not. I mean, it's not necessarily something that's going to happen overnight, but it is an inexorable movement, I think. And I think together with that is going to come over time margin pressures in existing traditional Ethernet segments, right? I mean, you're going to have. Right now you have an Ethernet switching business that has, 65-70% gross margin. and then you have say an x86 business that has, I don't know, gross margins in the low 20s or something. So there's got to be some change in that, right? I mean, you know, I don't think the 65-70% gross margins are sustainable. They may not come down to you know, x86 gross margins, but they will definitely come down. And
I think there's also a subtlety in that when people say enterprise network budgets are going down, what's actually generally happening is that branch and core budgets are going down, but security budgets are going up. And I think that's the angle. So if you think about what's the right attack vector to introduce SDN through, there's a set of security problems that have not been solved, like, you know, policy-based zone implementation where all of the rules between zones are automated, for instance, which are, you know, part SDN, maybe part what Illumio and those guys are going after. But that problem to me is the perfect attack vector because it hasn't been solved yet. Whereas, you know, the replacing of existing core, existing branch, everyone's looking for cheaper unit cost. They think it's commodity. And to your point, that the margins are so not commodity, people are looking at that going, I'm not going to pay that, you know. And so I think there will be an emergence of a vendor who is selling networking in that layer, white box, whatever you want to call it, that's on the 20% margin line and is actually delivering almost exactly what the 70% guys are delivering today. And you know, you can go to meetings and see presentations where you see transceivers from 3 different companies in the networking space with a 10x difference in price, but the underlying product is actually the same product in all 3 cases. So when I see that as a buyer, I look at that and I go, okay, I know where I want to take the cost out, but where I want to spend the money that I save is on solving the problems that haven't been solved yet.
Yeah. But would you take the risk with I mean, I'm sorry, just one question though. I mean, would you take the risk with a white box manufacturer at this point? I mean, presumably you are taking a risk, even though you know perhaps internally the components are the same, everything is the same. You are taking somewhat of a risk.
Where would you take the risk? So to me, you'd never take the risk in a data center, not first. You're much more likely to take it in the end user environment, which is the first place we deployed ProCurve, for example. So is it white box? Not really, not far away though. So my take would be you pick on the areas which are low risk in terms of implementation of that kind of technology, you test them properly, and then, or even better, you buy them as a service from somebody in the marketplace where if you don't like it, you just tell them you don't want the service and they take it away.
Just like we did with VMware in the early days.
Yeah.
Right?
Totally.
Exact same model.
Yeah, totally.
It's interesting you say about the security piece because, you know, we supply multiple services, but the security piece has been the one that's on the enterprise side where there's been the most traction. People are saying, I've got this problem, there's nothing really else out there for it. Let me start to insert that and then gradually make my move.
It's like APT, you know. I mean, when you see a vendor come in who can detect 95% of APTs that no other vendor can detect, and you're like, you know what, I'm going to buy that. So, and that's where these I wouldn't want to call them discretionary choices because they're not. It's just the threat vector for security has moved all over the place in the last 3 years, from, you know, the WikiLeaks, let's protect information, DLP, and all the rest of it, all the way to, you know, we're being exfiltrated now, and we want to figure out who's doing that, why they're doing it, where they're sending it to, you know, etc. So I think you're going to see that threat surface, to your point, continue to change, which will create the desire for, you know,
and the better margins.
Yeah.
So
totally.
One of the sort of bigger problems, though, with sort of this combined security and infrastructure view is that there's not just a silo of the fact that there is security, but there's a silo in information of what is relevant, what is the outcome, what is the intent of this infrastructure, much to your point earlier of finding ways to have policies that move with something in the infrastructure. That's part of where a lot of the cost is hidden as well. It doesn't take long to actually move a policy by hand from A to B, but somebody has to think about it right now. Somebody has to actively go through, figure out it's going to move from A to B and move policies accordingly with it. So while there's sort of a view in the market to look at pure CapEx, the reality is the bigger and the complex problems to be solved are those that are actually really complex. It's understanding which applications are actually permitted given, you know, a certain security posture for certain business groups. That seems to be the hardest problem to solve. But since that's the hardest problem, let's look at the least hardest problem, and that is let's look at what sort of commodity hardware does for us. And I have to disagree with some of the people on the panel that commodity or white box is the way forward. In the end, there's going to be a diminishing return of sort of removing software. Somebody has to write that software. Maybe we can reuse it from open source, that's great, but somebody has to write it, somebody has to support it. And if today's business model is that you buy hardware with 65% margins, but the operating margin of the company is actually much lower because you expense the software development, that's basically hiding the cost. There are 2/3 to 3/4 of the engineers are actually writing software. Somebody has to pay for that software going forward. So will that be sort of a Red Hat model where people sort of buy the software, buy management of it? Will it be a subscription basis? Really the question is, who's going to pay for the intellectual property that is created? And is that the application owner, or is it somebody higher up in those companies? I would like to kind of see if that's changing on the UBS side or on Boeing, or anyone else here. Do we see that sort of moving upstream?
Well, what I've seen is some resistance to it because of the realization that once the application starts getting more tied into the hardware, there's more exposure to the budget of that shared infrastructure. And so I've seen some actual resistance to it, but they're like, we'd rather almost be a dumb tenant because we don't want to incur the cost of that, suddenly now the whole apartment complex needs a paint job, right? And now they're incurring that cost even if they didn't want to. So, which has surprised me. I did not expect to see that.
Well, what I have seen in some customers, I don't know if it's exactly a change in terms of budgets, but what I have seen is that the application developers having a lot more say and a lot more influence, right, in terms of the way the data center is built and constructed, and in terms of the way the network is, even in making networking decisions, right, and in particular, the interest in SDN very often is driven by the application side of the house as opposed to the networking side of the house. Actually, very often the networking guys are actually the guys pushing back, right? Primarily because they view it as a, it works. Yeah, it works. Why break it? Your point. Why break it? I know CLI and I can do this in my sleep. Why rock the boat, right? And also there's a turf issue, right? It's taking away power from the networking guys, moving it somewhere else, and then there's kind of this uncertainty about what's going to happen. So I think very often it's the application guys and just the complexity of the data center is primarily felt by the application guys right now, right? Because onboarding a new application is a complicated, extremely involved process. And SDN, one of the primary value propositions is reducing that time to value. Right, getting an application in a virtualized data center on board, provisioned appropriately, getting the network set up right. That is one of the primary value propositions of SDN.
And as you saw touched on here a couple times, to tear it down as well. We want these just-in-time objects where I can instantiate a network, remove it. I can instantiate a compute object, I can remove it. They all become things that I can use as needed without there being a sunk cost in that. Now that's a lovely fantasy. How close we'll get to it, we'll see. But that I think for a lot of people is the goal.
Right. I think there's some resistance from the networking team because it's uncomfortable, and I don't really know what it is and what does that mean for my job. But I was at VMworld and talking to application developers and systems guys, and they were saying they're being asked to look at SDN because the network team actually doesn't have the tools to go and build what they need to do kind of a self-service dev test environment where they can click a button and order the infrastructure. And the only reason that they're involved, they don't actually want the responsibility for it, but it's not there otherwise, so they got to go fix it. So I think if you give some of the networking team the tools, more often than not, they're going to accept that and be more valuable to their organization. I think there's always going to be the pockets of, hey, I don't want to deal with this. Let's not broke, don't fix it. But
I think though there's a bit more of a fundamental problem than that, and that is, if you think about Maslow's hierarchy and just how people get comfortable with operating models, they get comfortable with what they know. Right, and safety is a value that you can't threaten, because when you do, you always get an immune response to that. So but my view is that you really have to lay out your vision for the target state and include the essentially resource abstraction and resource as a service as part of the target state, and make clear to people what roles will exist in that new world. In one of my prior lives at BT, when I went there in '88, we had 80% hardware engineers and 20% software. Sound familiar? And 5 years later, we had 80% software and 20% hardware. And you don't do that by chance. You design it that way. You say, I'm going to invest in retraining these people because the operating model's changing. And I think probably what we're not seeing enough of around the software-defined data center is people taking a stance. In our industry, people like Michael Hart at CBA has taken a stance and he said, we're going to do this. And then he's redesigned his organizational structure and the responsibilities around the target state. And we're starting to see other people do that on Wall Street anyway right now.
When you heard it, someone, I don't remember who it was, mentioned it earlier, maybe that's not the right model, but this whole idea of going back to this sysadmin role where it was, the thing that blew my mind when I started getting involved in some of these organizations is how distant they've become. To the point where they don't even care about each other's budgets, they don't even care about each other's successes, they don't even care, and it's like, you guys are getting your paycheck from the same people. But they've become so separated, these little silos have become so separated, and it wasn't that long ago that you did have, okay, sure, maybe some of the guys had more skills in networking, maybe some of the guys had more skills in Unix, maybe some guys were more security focused, but the idea of having a senior team that could go on call for each other, back up each other, respond to each other, support each other, and they were responsible for all of the technology in the environment, is a model that I would argue we shouldn't have gotten away from. And whether the future model is that or some derivation of that, I think what you said is dead on. You have to set that goal of saying, this is how we want to look, this is how we want to operate, this is how we want to be.
And you think about it, there's going to be at least 10 different execution venue types. Now we can all say, oh, it's going to be OpenStack. Well, guess what? It's not. It's going to be OpenStack, KVM, Azure, Amazon, blah, 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 right? So that means that if you can abstract that, so at least all your policy can be done consistently and you can deploy that into any cloud, that's a good thing. But it says something that your engineering people, the sysadmin people that you're talking about now, are essentially specialist cloud engineers. We understand how this particular blueprint is deployed on Amazon or on Azure or whatever. And I think, because, at least for us anyway, what other people call legacy, we call systems that work. And so the idea that we can move those into execution venues that run at half the price and essentially move the expertise away from vertical sysadmin versus vertical DBA into, cloud engineer. That to me has to be the right kind of outcome.
But you touch on the other problem, and that is that production data centers should be boring. Deathly boring. You should never hear, or I've never seen that before. Nothing random should ever happen in a production data center, right? So you're dead on. That should be very mundane and repeatable and consistent.
And work.
Yeah. I had a point, actually a couple of topics back, where I think Andy kind of touched on it a little bit, and it's kind of like to get some initial traction with SDN, you sort of have to get an intersection of a felt area of need or kind of a felt pain point, and then a relatively low risk on-ramp or a relatively low risk application. And I think you have that intersection if you look at what Andy was touching on with detection of like malware or looking at the behavior of APT type attacks or different things like that. Like Phil Porras over at SRI and his group have done some really interesting work with active security modeling using SDN. We're all familiar with honeypot networks and things like that. So it's just kind of taking that to the next level, where instead of just being able to to forward or to block a particular identified protocol, you can play a lot more games. You can pull it dynamically into sort of a sandbox environment, let it behave there, and have that be an automated process. And that might be a great initial use case for SDN, because that is definitely an area, a pain point. And as everybody's mentioning here, security is I think more than performance or quality of service within data center environments is much more something that I would look at. I would expect people to spend money on that, and then at the same time you're not putting your existing infrastructure at risk. You're giving a specific use case to this new technology, and everything else just keeps on working the way it's been working. So I think that would be a great first use case for it.
The truth is that IT groups are really good at managing risk. It's what they do, right? So most of these groups are going to adopt this technology as fast as they can that still allows them to sleep at night. And that's going to vary from a bank to a roller coaster company to a donut shop, right?
I think the interesting thing there, though, is if you can find an angle to introduce SDN that reduces risk. VTAP is a good example, but there are plenty of others. Give me something I can't do today. I don't want to plug Nixons in all over my network to figure out what's going wrong. You know what I mean? Network transparency as a service. I mean, all these kind of things.
You change the access model. You make it
You
easier.
definitely can.
Yeah,
And I think your point before about particularly net admins and sysadmins is really important, because getting data, if you're a sysadmin, around what's happening at the network is really hard. And VMware's play with Nicira in a way is fixing that gap. You know, their go-to-market
you could argue
is all
they
about
broke.
that.
Yeah,
So-
totally.
Sort of to add to that point, it's great that we're referring back to sysadmins in that day where, you know, one single role had visibility over everything that ranged from IP addressing to actual applications that run somewhere. But rather than looking back at the good old days of how things were, what is actually fundamentally missing when we talk about sysadmin role is know what the purpose is for why this particular role exists or why this particular application exists. Somebody high up in the tree who owns the application, who has a business logic question, they are the ones who know what the business priority should be. Is it 9 to 5 availability, or is it 5 nines? That information nugget on its own can drive and should drive what the infrastructure does underneath. Having that information pervasively available across operations teams, as well as planning tools, et cetera, that seems to be the large missing part. So I partly agree with the fact that sysadmins had a larger scope over what happened without necessarily going into all the depth. But viewing that in sort of a 2013 and onwards model would need to sort of account for...
Be policy-driven.
Understanding the abstraction of where we're going, where are we taking this. Because if I have to manage 5, 10, 15,000 applications in the infrastructure, I'm not necessarily interested in every individual one of them, but the relationships between them. And if we leverage that for security, for monitoring and operations, for troubleshooting, that seems to be a step forward. And it covers the understanding where the role is going to. It covers the understanding of where cost can be billed towards. If you've told me that it's got to be 5 nines, then I'm going to bill you differently, regardless of whether or not it's going to be across EC2, Azure, or the other options. So long story short, I think sysadmin roles, absolutely, but what we're really saying here, I believe, is we need to understand why that application is there so that we can make decisions. Where do we place it? Who do we charge for it? And who do we call for from a security perspective?
Any questions from the audience? We got about 4 minutes left. Yes, sir.
I'm interested in the panel's opinion on the following. Andy, you made reference to something very interesting. You said people do what they know. They're comfortable with it. You guys also have talked about other parts of how you treat the data center change. I want to take a step back and just make an observation about the hardware. The fact that different silos are evolving from a price performance standpoint. Back when, we used to talk about rules of thumb about how much network before I/O bandwidth. Alstal's law is one version. And if you do the math of what people were talking about when gigabit Ethernet server connectivity was, it was for every gigahertz of processor, gigabit per second of LAN bandwidth. That was sort of, it wasn't that you saturated it, but it was that if you didn't have that, you were going to clip and you were going to idle the CPU. Do the math. Kelly talked about it. We aren't close. I mean, with 20 cores and 2 gigahertz and 3 gigahertz per core, we're way off. It's like the observation is the following. People set the budgets, back to the point about silos. The NetOps guys are going to get this much infrastructure to manage in the budget, and the server people are going to get this much. And those have been roughly the same, and people can't talk about how do we optimize the overall performance. Seems to me the consequence of this is a lot of the discussion around rationing, quality of service, prioritization, creates this huge, I think, unmeasured stealth OpEx because people are either doing problem diagnosis or they're rationing bandwidth, basically. A rude term for quality of service. That if people looked at it in a different way and allocated more dollars to the network equipment relative to the server, better off. This is also aggregated back to the server margins have been crushed. Helped by Red Hat. Network equipment margins are still high, partly this. But I'm interested in people's opinion about it. Is there an OpEx thing we're missing when we think about how do we optimize the overall dynamism going on in the data center?
So, I mean, I definitely think there's always danger of, anytime you can hide something, people will, right? But I think that, there's an opportunity here from the point of view of, if you start looking at the way things evolve, you have a little more nimbleness, you have a little more openness, you might be able to get into some, slightly new ways of doing things. So I agree with you.
I actually think there's a slightly different approach here. So if you think about an AG switch architecture in a data center, for example, my view is you shouldn't ever build one of those ever again. And so, the way I've been encouraging people in our company and beyond to think about this is you're going to end up with a set of virtual private data centers, and they're going to be as big as a rack or two, or maybe 5, right? And you want to place workload, applications, databases, app servers, web servers that are interrelated in the same infrastructure, so you never hit the network. Everything's going on the backplane of the rack, and you're not actually going out to the network. So my view is that there's a segmentation change happening, and I saw this first when I was at Bank of America, where we had OC768 on the backbone of the data centers. And what's happening, I think, is the backbone itself is now becoming just a carrier for vPod to vPod traffic, is the way I think about it. But inside a pod, whether it's an Oracle Exadata or whether it's Dell's modular data center or IO or whatever it is, you want to keep as much traffic as you can inside it. And so the policy management that you overlay on top of where your workload gets placed has to do that for you, right? Because then you don't run into that problem. There's not quite infinite bandwidth on the backplane there, but there's pretty much infinite bandwidth.
But what you're talking about, and I think what you were getting at as well, is that, and I think it's kind of one of the pretty things that's going on right now, is that everyone has a similar problem, and they're trying to manage more stuff with less resources, right? And essentially, to me, it actually goes back to, I think, what you touched on with Linux, and that, there was a time where I could build out a Unix environment on, best of breed technology, and it was rock solid, and I needed a small number of guys to do it, and it ran well. And there was a time where to build that same Linux environment, it took more people, right? It took less money, but took more people. And so there was this kind of trade-off between, do you want to invest in the people or do you want to invest in the hardware, right?
Or in automation.
Or in automation, right? And I think we have a similar thing here now. If you look at some of the more fabric-based plug-and-play networking stuff, that's the more microwave oven sort of MRE sort of type thing, right? And then the SDN stuff's kind of more of the, you make your own noodles, you're an Iron Chef sort of thing, right? So what you're talking about, this Exadata stuff, it's the same sort of thing where that's gotten very specific, it's gotten very, good at what it does.
Yeah,
it's
exactly.
awesome at what it does, but to do that, it's made certain trade-offs, right? That may be good for them, may not be good for others. But it gets to your point of where do you want those trade-offs to be? Do you want to add complexity in software, which might mean a bigger dependency on humans, or do you want to assume lower trained humans and put that resource into building smarter devices? And that just ends up being the trade-off for everybody.
Yeah, but I think just to add to that, I mean, your point about traffic models and patterns changing, I think, is very appropriate, right? I mean, I remember, I forget exactly where I read this, but I read and maybe it's inaccurate, but I remember reading somewhere that Facebook sends 1,000 times more data internally within the data center, right, than they send outside of the data center. So for every bit they send out to an end user, there's 1,000 bits that are exchanged internally between servers, right? And that's a fundamental change in terms of the traffic patterns and the way in which data centers have operated, from previously where they were predominantly north-south as opposed to east-west. And I think that's obviously going to create some fundamental structural reorganization and rethinking of the way in which data centers are
but keep in mind, a lot of that pressure is due to what someone talked about before, which is this whole idea that the wide area network is underutilized and then the pockets are overutilized, and it's because of the barriers we build from the local to the external, right? We're creating that situation by essentially not letting the valves open and see how far you can push it.
Some of the use cases we see with our customers is in the pods and the elasticity pieces. One of the values that they bring, because they can automate it. Say, okay, at this time frame, I want to be able to crank it up, and I have a marketing event because that's what I do. And I know for this stretch I need it. I can turn it up using just x86 for the throughput.
Nice.
Get it up. When it's done, I can automate it. I can set the policy to bring it back down, and I'm getting better utilization out of what I need. I don't have to do granular capacity planning. I don't have to plan for just in case I need something. So I think the we'll call it SDN, or this agile data center, software defined data center, is going to get you to that point where various areas of the infrastructure can respond like that to solve some of those problems.
Yeah, no, I mean, I think we're starting to see it today, some lockdown stuff, but I mean, my brother now can spin up a whole new QA environment in 20 minutes. Engineering calls up, I need a new QA environment. He can have it ready for them. They're logging into it, installing software in 20 minutes. Now, the way he went about it might be too proprietary for you, it might be too expensive for you. That's a different discussion. But we're getting to the point where they can't, and let's face it, that's what humans want networks for. They want them for Easter and Christmas and transient events that don't stick around, and they're sometimes hard to predict. And so if we can't spin up and spin down resources to respond to that, then we're essentially, you're always trying to build to the common denominator when what you really have is a field of spikes.
Yeah, I agree with that. And I think also disaster recovery and crisis management is going to be one of the things that changes dramatically in the next 5 years for that reason.
I think with everything that was just said, if it's not broken, don't try to fix it. I don't think that applies to the infrastructure right now. I think we just called out a few of the examples of how we should make the infrastructure more flexible in support of higher layer application goals.
Well, there's broken, there's efficient, right? It can work, but I still want to get it better, right?
So, and I think sort of later today we've got Facebook to kind of confirm it's the 1 byte versus 900 bytes internally. I think I'd close with a remark that there's a lot we can learn from infrastructures like Facebook and Google. The thing, though, is that they essentially have one application or maybe a handful of applications that are very custom built, made to use everything that's possible inside of distributed systems, whereas a lot of the large enterprises still have to take care of 5,000 to 10,000 applications that are, they're legacy, but they work, as was said. So how do we take that forward? And I think uniquely what's good about Facebook, Google, et cetera, is that they know exactly when load is going to happen, where it has to end up, because they know what the intent is of the entire infrastructure. Getting to that level might take a while in enterprises, but we have to start, as mentioned earlier, security policies, blueprints of infrastructure, and essential affinity information of what requires talking to who, to where, and when.
All right, how about a hand for our panel? Thank you, gentlemen.